All right, I want you to think of, so the induced fit, right? In this one, all right, let me put a diagram on the board. So that's not good. I just use your imagination, all right? Okay. And then let me do this. So we're looking at induced fit now. So let us say you have a non-stretch, it's not stretchable. Right, let me just, so you have one material that you are not able to stretch, all right, and one that is flexible or non-flexible material. So it can stretch, all right? So it can stretch, right? So if you order a size, a particular size for person A, it should not be able to fit person B, all right? If you order a material that is not able to stretch, right, for person A, it should not be able to fit person B. And if you buy the material for person B or the clothes for person B, it should be too big for person A. Now, what the induced fit hypothesis is suggesting is that the enzyme becomes flexible. So basically, if you buy the clothes for person A, because the material it can stretch, it will stretch to fit the shape of person B. Person A and B are of different size, but the clothes it's going to change its shape to fit whether it's person A or B. All right, so it's person A, it will not stretch as much. If you put it on person B, then it is going to stretch to accommodate the shape of person B. The key thing here is that it is changing its shape to fit the particular person. In this case, the persons are the substrate. All right. So the persons, they are the substrate. Substrate 1, substrate 2. But it doesn't matter how they shape the enzyme. So the material that is flexible, so the flexible material, that is the enzyme. So it will fit either persons because it will just change its configuration to fit the person. All right, so I'm just checking for this one. Do you understand it? Just checking. If you have any question, you can ask. All right. So the key difference here is that in this one, the enzyme is going to change its shape to fit the substrate. So we are not viewing it that the substrate is specific for the enzyme, but rather the enzyme is going to change its shape to fit the substrate. So let me put that in words. Yes, the active site, right, it will change because that is where the enzyme is going to, sorry, that is where the substrate is going to bind. So it has to change to accommodate this substrate. And so let us do an example or a diagram to see what it looks like. All right, so again, let us say this is our enzyme. So again, let us say this is our enzyme and this is our substrate. So clearly, this substrate cannot fit this active site. So what would happen? That the enzyme would need to adjust its shape. So probably something like this. All right. And so the substrate can now fit inside of it. So this is the active site. This is the substrate. Notice the active site has changed shape. So that is the key difference between lock and key and induced fit. Lock and key tells us that the substrate has the specific shape for the active site. So this would be the lock and key. But with the induced fit, the substrate don't have the specific shape. But the active site, right, it will change its shape to accommodate the particular substrate. All right. So that is the difference between lock and key and induced fit. How does it change shape? So it would have to be, so remember enzymes are proteins, right? And when, so someone asked, how does the active site change shape? Once the enzyme is going to change shape, the bonds that are presently there, so remember, of ionic interactions of hydrogen bonding that keep the three-dimensional shape of the protein intact. Enzymes are protein, and proteins are folded into three-dimensional shapes. So that means the bonds will have to break to change its configuration. So when we look at, so you can view it as how you view denaturation of the enzyme. When the enzyme is denatured, it's changing its shape, which means that bonds are broken. If it is going to accommodate, once it is changing its shape, a bond has to break. All right. So basically, the bonds that holds the 3D structure together, some of them has to break in order for the conformation of it to change. Understand the person that asked? All right, so that's what happened. Okay. All right, so let me just write something now below it for the induced fit.